morning, magandang umaga sa lahat. So I'll be retracing some of the points raised already by Ben Horton earlier. Well, let me start with this diagram. Pinapakita nito bale based on sea surface height measured from space for the period 1993 to 2009. Ito bale yung average na pagtaas ng dagat sa paligid ng Pilipinas. And you can see some numbers there. May number 7, may number 6, may number 8. Those are average rates of sea level rise for the period 1993 to 2009. Overall, sea level, wala pang ginagawa ang lupa dito. It's only eustatic moving. Roughly, it's about 1 centimeter per year. And a study by Wright, Brook, and others, they were able to document the fastest rate of sea level rise globally for the period 2002 to 2014 within the area of the Philippines na nasa 1.4 centimeters per year. So tandaan natin yon, no? I-average na lang natin 1 sentimetro kada taon ang itinataas ng dagat sa iba't ibang bahagi ng Pilipinas. Now, on top of that, gumagalaw ang lupa. So there are local factors, a lot of them. But for today, mag-concentrate lang tayo doon sa subsidence at saka sa tectonics. Okay? Konti lang ang panahon, kaya mag-focus lang tayo doon. Ito yung tide gauge record. This is from work from years ago, 2003. The upper panel is for Manila. The green line, that's average or sea level annual, okay, through time from before 1910 to just after 1990. And you can see it rising rapidly after the 1960s. We've correlated that with the groundwater obstruction for Metro Manila at maganda yung fit niya. Kaya sinabi namin na itong nakikita natin dito na accelerated rise of sea level is caused by over-extraction of groundwater. Now, Ben pointed out Cebu earlier, so let's go to Cebu, which is this figure right here. Makikita nyo, through time, ang dagat ay bumababa. No? Meron siyang negative rate dahil sa yung lupa ay umaangat, no? Tectonics ang dahilan dito. And then Holo is behaving in a similar way. Dati ay umaangat and then very slow yung kanyang yung sea level rise after the 70s. Sa Legazpi, meron ditong complication nung inflation deflation ng Mayon volcano. And Davao is a deltatic system, so it's also experiencing compaction of sediments underneath, so the area is also subsiding. Now let's look at Metro Manila. Etong mga diamond shape na yan, those are benchmarks. And those benchmarks were occupied by NAMRIA in 1978, and then they reoccupied this benchmarks in 2000, and based on their own report, there is a change in the elevation of these benchmarks. The numbers that you're seeing here it's in meters. So ang pinakamalaking change dito ay ito, 1.46. All of those should be in the negative. Itong bahaging ito ng Caloocan ay lumubog ng halos 1.5 metro sa loob ng 22 taon. Bakit ba ito lumubog? No? Makikita natin yung matingkad na bato, that's adobe, that's volcanic material, which is difficult to compress. And then the light yellow materials are coastal deposits or alluvial deposits, which are readily compressible. And yet, if you look at the values of subsidence, they cut across the different types of lithologies. Ibig sabihin, hindi lithology ang control. Ang control dito ay groundwater withdrawal. No? Pero hindi ko na ipapakita in the interest of time. So for this, if we look at the entire Philippines, ang dami-daming munisipyo na dependent sa groundwater. Pero if we over-extract yung groundwater, ang effect nun ay lulubog at lulubog ang lupa. Kaya siguro dapat na nating i-move ang mga sarili natin na kung saan available ang surface water resource, itap natin siya for our domestic and industrial use. At sana ay maging isang policy ito ng Pilipinas. Ang paggamit ng groundwater ay hindi lang naman sa mga bahay, ginagamit din ito sa mga palaisdaan. So this is the delta plain north of Manila Bay, and that whole delta plain is populated by fish ponds that utilize groundwater. The numbers that you're seeing there is the change in the height of the highest tide between 1991 to 2002. So we did interviews all around this place, and we asked for their observations on the change of the highest tides na walang ulan, without rainfall. And in this area right here, dito sa left side nyo, upper side, meron doong change ng 1 meter. Samantala, bumaba dito sa Orani, that's roughly almost a meter as well. So all over the delta plain, it's as if sea level is rising anywhere from 2 to 9 centimeters per year. Na kanina si Congressman Chato, no, nung time na siya yung governor sa Bohol, ay lumindol, no, October 15, 2013, magnitude 7.2 yung lindol. At itong litrato na to, this was taken roughly around December. And you can see this brown area, Loon, Punta Cruz, and Maribojoc. That's the uplifted reef. No? Inangat siya nung lindol. Nagkaroon ng co-seismic uplift. And the photo dito sa lower right-hand corner, that's Sporites. It's a coral that lives under water. Pero umangat yung lupa, kaya ayan, hindi na siya makaligo. Eventually, namatay na siya. We did some estimations of the magnitude of uplift, and we were able to calculate anywhere from roughly more than half meter to 1.57 meters of uplift. And for this area that was uplifted, that's roughly 548 hectares. Isang side ng Bohol, no? So may umangat, pero meron ding lumubog. At nabanggit ni Congressman Chato, itong isla ng Batasan kanina, ito ay isa sa mga isla na lumubog. Lumubog siya anywhere from almost half meter, 0.43 to 0.76 meters. Bilang-bilangan, half meter, Ubay, Pangapasan, Inanoran, and then within the mainland, Pook, Occidental, and Centro Cebu, lahat din ay bumaba. But itong Bagong Banwa at Mocabok, nagpunta rin kami dyan, walang indications na siya ay lumubog. Ito ang litrato sa Ubay at 1.8 meter high tide. Ito yung bahay, ayan na siya, pwede nang lumangoy ang tao maski sa loob pa lang ng bahay. Pero katulad nga ng sabi ni Governor Chato kanina, ayaw lumisan ng mga tao. Gusto nilang manatili doon sa kanilang mga bahay. Let's look at the geological record, patterns from the past. There are a lot of indicators that one can use to reconstruct paleo sea level. And it is a good thing that in the Philippines we have a lot of coral reefs. And corals, building the coral reefs, we can use them to reconstruct sea level. This is a photo taken from La Union in Paruwir, and you see this roundish things, okay? Pabilog siya. Those are microatolls, and they live almost right at the mean sea level. But these microatolls are about 1.4 to 1.5 thousand years. So, ibig sabihin nito, dati itong lugar na ito ay below sea level, pero ngayon ay above sea level na siya. And in the work done by Mabel Abigania, ito bale ay indicator ng dating paleo sea level na ang dagat was about 1.5 meters higher than present. This is from Currimao, Ilocos Norte. Isa itong bato na binuo ng skeletons ng mga coral. So through time, the corals secrete or produce coral skeletons, and they get stacked one over the other, and then tumitigas siya, it gets lithified, it becomes rock. We were able to walk the top of this rock formation, itong nakalagay na terrace, and we can see corals in living position, and we were able to date them around 7.6 to 6.5 thousand years ago. Itong features na ito ay very common all over the Philippines. Hindi lang ito sa Ilocos, makikita mo ito sa Palawan, makikita mo ito sa Mindanao, east side, west side ng Luzon, makikita mo itong mga ito. And then, isa pang indicator ng paleo sea level are the marine notches. And this is a photo taken from Palawan. Meron dito na sa pinakaibaba, makikita nyo may nakapasok. It's indented. There's a notch just underneath this outcropping shells of oysters. And then you see 3 more over here based on age dates. Itong lower 3, those are all in the past 10,000 years, and the upper one right there is about 120,000 years old. Combining all the data sets that we have for the Philippines, mainly for places like in Samar, Buyayawan, in Tanabonan, in Palawan, and in Parawir, dito bale sa diagram na ito ay this is sea level in meters, and this is time from 8,000 years ago to present. So moving towards the present at about 7.5 thousand years ago, sea level became higher than present. Ito yung present sea level. It popped up and stood still for some time, and then popped up again, stood still for some time. This higher than present sea level during this period, which we call the mid-Holocene, is consistent with the warmer temperatures of the period, yung tinatawag nilang Holocene thermal na optimum. But we see here, nagbabago-bago yung elevations across study sites, and we attribute that to tectonics. But if you look at the patterns, you see similar shifts timing-wise across the different tectonic regimes. And we interpret that to be due to eustatic.
Sorry, Doc Ando, you have 90 seconds left.
Okay.
You can budget your presentation.
Halos huling slide ko na to. July 23, 2020, lumabas ito. Ang sabi lang, Antarctic ice sheet can still collapse and add 3 meters more to sea level rise in the more immediate times. This is not even yung long period projected earlier by Ben. If you melt all of the ice masses in Antarctica, sea level can still go up by 30 meters. So takeaway for all of this, eustatic sea level rise will continue. We have local amplifiers of sea level rise. We have episodic large rises of sea level, which may still occur in the future, and therefore, it is essential that we know the directions, styles, and rates of vertical motions of our coast. We should minimize the local human-induced causes of sea level rise, and there is a need to shift the focus of development to higher grounds accompanied by continuing efforts to protect our coastlines. Maraming salamat. Gandang umaga.